So, hi there, everyone. My name is Ted M. Young, and lately, I guess not lately anymore. It used to be new, but now I guess it's. I've been teaching about hexagonal architecture for 4 years now, but it's still new to me. I still learn lots of things every time I teach it, every time I talk about it, every time I explore it, and this is basically my latest thinking on it, which is. There's always places where it's subject to change and subject to clarification, but this is the latest, best way I know how to make code more testable. So testability of code, I'm an old Java guy. I've been doing Java since it was around. And for the longest time, testability, unit testability of code is been really important to me. Being able to verify it without having to do the manual testing of things is really important. Way back when I started, that was somewhat rare. These days, hopefully, it's not as rare. But still, it's easy to say, oh, I can unit test this method. But how do I unit test like systems and how do we sort of organize them to be testable? And so that's hopefully what I hope you get out of this is a way to think about your code bases using hexagonal architecture to make them more testable. So you can see my contact information on all the socials is JitterTed, except for LinkedIn where I'm just Ted M. Young. Not to be confused with Ted Young. There's another Ted Young, but he and I are two different people. This presentation actually, as I mentioned, I teach this. I am now a Java trainer, technical coach. And a lot of what I do is work with teams to help them make their code more testable. Using hexagonal architecture and test-driven development and refactoring and things like that. And so this is actually a full-blown course. It's a dozen hours or so that I teach, and I'm actually going to be launching a self-paced version of this. So if you're interested, there'll be a link to that later. Ask questions as you need. I'll hopefully be able to monitor chat, but if you have any questions or there's a question and you feel like it's going to prevent you from understanding anything else, just ask. Because I'd rather take a little bit more time to explain something than have trying to build onto that and find out that it's like, oh, I didn't understand that first thing. So what is architecture, right? So there's lots of answers to this, but mainly what I'm concerned about and the way I think about architecture is really kind of two different ways of thinking about it. One is it's the organization of code, right? So how do we package our code, put it in namespaces, whatever mechanism we use. And then there's the deployment aspects, the operational aspects, the visionary, how are we going to have multiple systems and basically architect a system for our organization or multiple organizations. And one thing that's really interesting is to me, this is the difference between layers and tiers. So I know I always used to get those confused, like layer, is this a multi-tier system or multi-layered system? And so for me, the organization of code, how do I layer my code? How do I subdivide it into areas of very precise responsibilities? That's all code organization oriented. And so that's layers. Then tiers is like, well, how do I distribute this onto hardware? So those are the way I think about the differences of the different kinds of ways of talking about architecture. So if you've ever seen this before, you may know this as variously as a vertically layered architecture or a cake architecture. I grabbed this one from Microsoft's site mainly because it has pretty colors, not because I think it's correct or the right way to do things. It is an architecture. But one of the things that we can see is that it is vertically stacked, right, from top to bottom. So kind of the idea is inputs to the system come in from the top, and we write things out to a database at the bottom. This is great, and you can have discussions and debates and arguments about what do we do between the layers? Can this presentation layer talk only to the service layer, or can it skip a layer and talk to the sort of the business layer, if that's what we want to call it? Generally, it's sort of downward in terms of flow of information or initiation of information. You could also think about it as dependencies are generally downward. The problem I have with this architecture is that it tends to lead to database-centric systems that are all about the data. I'm an object-oriented guy. I love object-oriented programming. I think it's great. I'm obviously biased because I've been doing it for pretty much for my entire career. So it's kind of the only way I know how to do things. So I think it's wonderful. But I do think it actually has worked well for me and for the systems I've worked on. And I've worked on some huge insurance systems for policy claims and billing. Like, these are the ones that are behind multi-billion-dollar and multi-billion-pound systems. And object-oriented, when we do it right, has generally worked really well. But database-centric pulls us away from that. And so really what we want domain-centric. And this whole idea of domain-centric, I really loved Domain-Driven Design, the book from Eric Evans. In fact, I was lucky enough to, when he was working on the book, I was part of a group that he basically had us review it and work with him on it. And so I've been sort of a big fan of this book since the early 2000s. And if your system is a CRUD system and all you're doing is essentially editing database tables, well then great, go do that. Although I would say, why bother writing any code? That should be code generated directly from the database tables. But if you have a non-trivial domain, right, a complex domain, right, whether it's business oriented or technically oriented, like it's managing hardware and network systems, or it's a game, whatever it is, that's your domain. And if it's complex, you want to be able to focus on that separately from the rest of the world. So when I develop systems and I thought about, how this relates to sort of the vertically layered architecture, there's this term thin vertical slices. And here, what we want is to be able to develop sort of a full feature, right? It's been quite a while since I worked on a team that was solely focused on sort of just one of these layers. Like, hey, we're just going to implement, this data layer and maybe a little bit of business stuff. But these days, and for me, since I'm an extreme programmer, I don't call myself an agilist anymore because that's gotten a bad name. Really think about developing functionality because I want fast feedback. So we think about developing those as thin vertical slices of behavior that may touch all these parts of our architecture, of our code organization, but provide some kind of feature that we can actually see and get value from. To me, that's the fundamental aspect of extreme programming, is get value quickly and get feedback quickly. And so as we develop this, we sort of add on. So we develop, some additional features and develop and use code from, right, what we already developed. It links it, and maybe, we have code dependencies between these things. And as we add on features, right, we've got code that uses methods that we've already written, and so on. The problem comes, at least from looking at architecture and code organization this way, is if we need to take away one of those features or modify it heavily. For example, let's say we were supporting an old phone, and we don't want to support that phone anymore, right? It's obsolete. And so we want to take out all of the code relating to that functionality. Well, now we've got some problems because we've got some code that, well, what do we do with this code that these other slices were depending on? Now we got to sort of pull them apart and kind of get rid of that so we can get rid of this functionality. And that's kind of a problem. And one of the other issues is often just a looking at the project and having it very oriented at very sort of technical ways of structuring the code makes it really hard to find, well, where's this feature for adding products to our catalog? Okay, maybe it's in a controller somewhere, and maybe there's a domain model somewhere. Who the heck knows? So hexagonal architecture, I was introduced when Alistair Cockburn, who basically invented it, who wrote it up, because I'd been following Alistair Cockburn for years. He's written a lot about object-oriented programming and use case design, and one of the signatories to the Agile Manifesto. Been around for a while, and I'd read about this when he wrote about it in the early 2000s, but didn't really have a way to apply it. And it wasn't like he wrote a book about it. It was a long web page, and describing it as a pattern. And at the time, I didn't really see how to apply it. But over the years, especially over the past 8-10 years, I've been really focused on, I need to make my code more testable. What do I need to do to make it more testable? And we'll see some of the things that really help to make the code more testable ends up fitting very well with hexagonal architecture. So as you can tell by the name, one of the most important things is that it's a hexagon. Now, of course, this is a diagram shape, right? It's not like we have hexagons in our code, although I would love that because I'm very fond of the shape. But the idea of hexagonal architecture is when we diagram it, and I think having these visual representations of what does our code organization look like is very useful. And Alistair basically said, look, it's not the number of sides that's important. What's important is that we think about it differently than we think about sort of stacking up rectangles or putting them side by side. So he wrote that he wanted this hexagon shape to break up perceptions about top and bottom and left and right. He wanted to really have this focus on there's stuff inside and there's stuff outside. And he wanted it to have facets, right? He wanted to have these edges. And we'll see, because we can sort of attach things to those edges. And he wanted something larger than 5, but also a shape that was easy to draw. So he ended up with a hexagon. And hexagons are easier to draw than pentagons. So there you go. So I'm going to let you read this, and I'm going to talk about why I highlighted some of this text. So Alistair Cockburn wrote this, and you'll notice that it's also often referred to as ports and adapters pattern, because ports and adapters are two important pieces of this architecture. But most people, myself included, refer to it as hexagonal architecture, because to me it's more than just these ports and adapters pieces. It's really the whole way everything fits together. And so this idea of allowing an application to be equally driven by users and programs might be other systems, and automated tests is really fundamental to this architecture and thinking about organizing our code. Right? The idea that our core application code, and we'll look at what does that mean? What is the core application code? It's basically the thing that we're paying for, right? Implementing the rules and business process and invariants and all protocols and all that makes up what is this application supposed to do? What purpose is it serving? What problem is it solving? And so allow that application code to be driven in exactly the same way by a user running on the real system, and a test means that it's going to be easier to develop. And then developing it and being able to test it in isolation from those real world things. That's what we want. I want to write lots of unit tests that are isolated from devices, databases, basically hardware and I/O. And hexagonal architecture is all about that. So what Alistair basically means and intends for this is again, that there's this hard boundary. There's this hexagon, and everything that is inside is purely about what is the domain, what is the problem we're trying to solve. But by itself, if you have code that knows rules and processes and workflows and things like that, unless we communicate it to and from the outside world, it's kind of pointless. So we need to connect it to the outside world through various mechanisms. So inside is our application and domain code, right? If it's a game, like a game of checkers or a card game of blackjack or poker, these are all the rules and the objects representing the pieces and the board and the playing cards and so on. Then we've got the outside, and this is basically the rest of the world. And so how do we communicate that we intend changes to be made, right? If I'm playing a game of poker and I want another card, I need to be able to indicate, hey, I'd like another card, and I'd like to drop these other cards. And so we can divide the outside world into two parts, because that's what we like to do. We like to divide things into parts. On the left side, we've got the user side. Now, it doesn't mean it's an actual user, although ultimately at some point there is some user. But by user, we basically mean something from the outside that's initiating behavior in our system, right? Inputs into our system, requests against our system, right? Inputs meaning I want something to happen and maybe change. So if it's a little banking system, I want to be able to deposit money and have it accept that deposit and increase my balance. Or it might be a request of how much money do I have in my account? And so give me the balance. So that's the input side, the user side. And then there's the data side, which is basically outputs. So it's not just sending messages to other systems, but it's also storing information, right? We don't want to store stuff in memory generally. We want to put it into something a bit more long-lived, like a database. So we've got outputs writing to those kinds of things like databases, and we have maybe looking at it as events being sent to other systems. Hey, you've dropped below your $500 threshold. I'm going to send you an event, and it may show up as a text message to let you know that you might want to deposit some more money. And so one of the nice things about this diagram is this both symmetry and asymmetry, right? Symmetry in that both of these things have an outside part, right? A user side, an input side, and an output side, but that there's this flow from left to right. And so we have an inbound request of some sort or input saying, I want to change something or I want to get some information. That hits the application code. And the application code just sits there waiting for somebody to tell it to do something. And then once it gets this input, then it does some work. And then once, as part of doing that work, it might need to store some information. It might even need to go and request information from another service. Maybe I'm doing a currency conversion because I've deposited pounds in my account that's denominated in US dollars. So I need to find out what the conversion rate is before I can complete that piece of work, that unit of work. So we have this left to right flow where things are initiated and come inbound into the system on the left, trigger our application domain code to do something, and as a kind of a side effect, although it's not really thought as like a side effect, we write things and we request things, and then we send out events indicating that something happened. So one of the first projects I created from scratch to be sort of my way of implementing hexagonal architecture is a little project that I created to help my son manage his money and his parents too, because he's too young to have a bank account. So we need some way of tracking sort of his virtual money that he got as gifts, money that he earned by helping do things, and also, of course, money that he spent on buying video games and candy. because that's what boys do. And so I developed this application, and it's still running years later, test driven all the way, and organized the code according to hexagonal architecture. And it's open source. You can look at it, and you can follow it. It's sort of I look back at it and I see, oh, I've learned a lot about how to organize certain things, and some subtle changes in the way I think. Haven't had a chance to push back into the code. There's another application that I think is sort of more modern that I'll talk about. But this one really was nice. One of the reasons that it was a good example is that there are two different ways of interacting with the system. Two different ways to send input, send requests and changes, and also request information. So on the left side, we've got typical, somewhat ugly, because I'm not a designer, web UI. And then on the right side, we have a text message based interface. And this was because a lot of times we'd be out and about, at least when we were out and about a lot more than we have been recently, where we'd be at the store and he'd buy something and I'd need to record that. So I used to write that on a little piece of paper, stuff it in my pocket, and hope I remember to put it in the spreadsheet when I got home. But this way I could just send a text message, which was nice because I have an iPhone, my son had an Android phone, and so I didn't want to write two different apps just for this one purpose. And really, there wasn't a lot needed. I just needed to be able to say, hey, deposit or spend. So the text message interface is actually the one we use most of the time, because it's a lot easier to just pick up the phone, send a text message, than to open up a browser, log in, and click a button. And so if we look at this application and we diagram it according to hexagonal architecture, what it looks like is, okay, we've got our hexagon, and we've got a web UI. Right, so that's the one that we saw on the left side, and we have another input, another inbound adapter for text message handling. So these are the inbound adapters. These are the way that we send input into the system and initiate work. What they connect to is the application layer. And what the application layer then serves the purpose of mediating and managing the requests that come in and how they interact with the core domain. And as part of the core domain doing its work, it may need to save some information in a database, right? I've just done a deposit. It needs to make that change permanent. And so it needs to talk to a persistence mechanism. But inside this hexagon, we can't be aware of any concrete hardware because we want to remain, in a sense, pure. We want to remain domain pure, where we have no concepts of specific I/O and hardware. And this allows us not only to separate our concerns, which I'll dive into, but also it makes it much more testable. Because I can write tests against this boundary, against the application layer boundary, as well as tests against my core domain boundary. And they're pure unit tests. There's no I/O at all. And they're going to be easier to write and run quickly, which is what I want for my tests. But ultimately, at runtime, we do store it in a real database. In addition, we might want to send out a text message saying, hey, you've reached your goal in saving for this video game, right? So that's another port and adapter. And so these ones on the right are called outbound adapters. So this is a diagram then of, at a high level, of the KID Money Manager system. We've got two input mechanisms, and we've got two output mechanisms. And that everything in the center, that's our domain. Doing things like managing transactions, calculating interest, because he gets interest. I guess I'll have to bump that up with the recent increase in interest rates here in the US. And it also tracks saving goals and things like that. So that's the core behavior. How it interacts with the world is that's isolated into the adapters. So if nothing else, separation of concerns is, to me, the magic sauce. And it's not like we weren't separating concerns with a vertically layered architecture, but to me, it's much more clear about what those concerns are and where to put the code for each of those concerns in hexagonal architecture. And so what are those concerns? They're basically two, right? We've got our infrastructure hardware in the outside world, and we want to keep that and those concerns, how we integrate with them, how we listen to them, how do we notify them, how do we fetch information from these things, from our domain logic. And we want to keep those separate. And by hardware, I mean the big things as well as the little things, like what time is it, right? Accessing the clock, that's hardware. If you know anything about testing, and if you have anything that ever dealt with the day or time of what day is it, what time is it, you know how hard it can be to test that if you don't have a way of controlling what the test thinks the clock is currently set to. So by keeping this separation, magic happens. So what this looks like is we've got our core domain, we've got our application layer inside the hexagon, right? And so they are separate from these things that we have on the outside. So we might have a console connected, we might have a messaging system like Kafka, things like frameworks. So whether it's Java frameworks like Spring, Jakarta, Micronaut, if it's other frameworks, we want to keep those outside the picture. We want to keep those outside of the hexagon. We still need them, right? Because we still have to communicate with these external systems like databases, networks, and file, but we want to keep them separate. And it turns out this fits very well with how Michael Feathers, who wrote a book called Working Effectively with Legacy Code, among other things, back in 2005, came up with a list of rules, what he called a set of unit testing rules. And the ones that are interesting are, he said, it was almost like a list of things that would make a test not a unit test. And again, what I want, if you think about the testing pyramid, I want lots of unit tests, fast to run, very precise, easy to write, and generally pretty stable. I want to have mostly unit tests in my system. And so Michael Feathers says, well, if it talks to a database, it's not a unit test. It's probably a useful test, and I'll write some of those, but it's not a unit test. If it communicates across a network, not a unit test. Touches a file system, not a unit test. And so he has some other rules, but they're all around touching hardware, doing I/O, makes it not a unit test. In fact, what I call these things, I call these integration tests. Now, there's like 5 different definitions of integration tests, but to me, what I use is the principle that unit tests are isolated from I/O. If it touches any kind of I/O, a clock, a file, a database, even if it's running in memory, that is I/O, that is hardware, that is infrastructure. That means it's not a unit test. And what I generally call those is I call them integration tests. I'm integrating with I/O. I'm integrating with hardware. If it's isolated from all that, it's a unit test. If it runs basically in RAM on a CPU and touches nothing else, that's a unit test. And so what's great is then everything in here, inside the hexagon, testing this stuff, it's all unit tests. So we can remember back to the paragraph that I quoted from Alistair Cockburn, right? We have unit tests here that act like input from a user or input from an external system, except we're driving the behavior with an automated unit test. And so this application layer, this core domain, has no idea, right? It is not aware of how it's being driven or who's driving it. All it knows is that it's being asked to do things and asked to provide information. Whether it's a unit test that's doing it, or a web UI, or an incoming message, doesn't matter. And that's what makes this, I think, so powerful, because it makes it this really clear separation. Now, in order to test some of this, though, you may need to fake out some of your outbound systems, right? If I need to test this and some of it is involved in pulling things, writing things to a database and pulling it out later in that process, then I need some kind of fake database, because if I have a real one, well, that's no longer a unit test. So I want my unit test to run quickly and run fast. Therefore, everything that is needed, all the dependencies, like we need to store and retrieve things from our persistence. We need to at least pretend that there's some service here that returns some value. Those have to be in memory. And that's what test doubles, what's sometimes known as mocking. That's what this is for. Because we're not testing these things out here, we're testing the things in here. And we'll look a bit deeper into that in a little bit. So this core domain, what's in there, right? So our application layer is the thing that's sort of coordinating with the outside world, even though it has no idea specifically what database we're talking to. It talks through a port, which I'll mention in a second. So what's in this core domain? Well, it's back to domain-driven design, right? Domain is the focus of the application. And so what's inside of that inner hexagon is our core domain designed according to domain-driven design concepts. And so the things we find in there, if you're familiar with domain-driven design, you know there are these tactical patterns, basically these. And so domain-driven design tells us that, well, one of the things we want is actually a layered architecture. And hexagonal is a layered architecture, right? There's an adapter, that's the outer layer. There's an application layer, and then there's the core domain. That's a layered system. So we've got our layered architecture. So it happens to fit very well. Domain-driven design was written in 2003, 2004. Hexagonal architecture was written by Alistair Cockburn in around 2005. So it's interesting to see how these two things are looking at the same thing in just a different way. And that domain-driven design fits perfectly with what goes in the center of the hexagon. So specifically what goes in the core domain are are entities, value objects, and then this thing that groups these things together called aggregates. And then in the application layer, we've got repositories and services. So I already talked about services. Really, that's what's in the application layer. It's a thing that coordinates loading and saving and communicating with external systems. What's in the core domain, though, are these three: entities, value objects, and aggregates. So what's an entity? It's something that has information that's unique in some way, right? It might be a customer, it might be an account, it might be an order. All these things are unique, even though they might look very similar, right? If you and I are shopping online and we're both shopping at Amazon, just because we have the same domain-driven design book in our cart doesn't mean that they are the same cart. They belong to two different people. They are two different carts. And so because of that, they likely have some internal identifier that helps us tell the difference, because maybe the name of the customer is the same, right? There are lots of Ted Youngs out there. Maybe they all have the same book in the cart, but they're different. And so they are unique. And that uniqueness is basically due to it having some kind of identity. And so often we come up with ways to make sure that those identities are unique. We usually use some sequence, or maybe a GUID, a globally unique ID, something that makes sure that we'll never have a collision there, because using any of the properties of that entity is not going to be useful. Right? The name on the cart, their email address is not even useful as a differentiator. So that's an entity. It has history, it has attributes, it has information that changes over time. So often it's mutable. Then we have value objects. So value objects are all about what is this attribute? What is this describing? And so value objects we look at is basically quantifying, describing, and measuring other things. Right? So if we have a book, we might have a value object that represents, well, how heavy is it? So we can later on figure out shipping costs. We might also have, what color is it? Probably not for a book, but for clothing, that's probably important. For clothing, it might have things like, well, what size is it? So these are all value objects because red is red. You don't need some unique identifier to figure out how to call something red. So entities and value objects are the things that make up the bulk of our domain. If it's a blackjack game, we've got playing cards. Those playing cards have suits and ranks. Card, suit, and rank, actually, those are suit and rank are all value objects. Cards are immutable, but maybe want to uniquely identify them. Then we have players and hands and dealers and games and so on, and those are all entities. And so the way we group those together and the way those act together is where we get an aggregate from. So an aggregate isn't a separate object, it's the way we call a group of objects working together. So if we have an order, we have the order itself, which has information, and then we have pieces of that order, like what are we ordering? Well, we're ordering a board game, and we're ordering a book, and we're ordering some clothing. Those are individual items. And what the aggregate does is it's basically our sort of transactional consistency boundary, right? So if you may not be able to buy more than $1,000 worth of goods. And so the thing that limits that is not the individual line items, right? They don't know, they just know how much they cost, but it's the order itself. And so we talk about this boundary being enforced by one of those entities that knows what is the value of the whole thing. It knows about all the other objects and can enforce that integrity. So specifically, what you end up with is often multiple aggregates, right? You've got your buyer aggregates, all the information about who's buying it. You have an identifier, so that means that this is an entity. It has a full name. Name is probably going to be a value object. Payment methods are probably going to be value objects. And it has methods to basically work with and modify it. Aggregates, from the name, sometimes sounds like it has to be a whole bunch of things, but it doesn't. It can be a single entity. But often it's going to be entities and a couple of value objects. But sometimes it's just a single entity. And then we have order aggregate. So here we've got an entity, and then we have another entity. Although order item could probably also be a value object, because maybe if we want to replace it, we just throw it away and create a new one. But the idea is that order is how we interact with the whole aggregate. When we place orders, when we remove items, when we add items, when we try to figure out, hey, what's the total? When we want to enforce consistency, that's what order does. Right? It's kind of like the container for all these other things. And then we've got address and other things that are value objects. And so this is another aggregate. That's all I'm going to say about aggregate. It might still be confusing to you. Don't worry about it. It doesn't come up anymore in terms of hexagonal architecture, but it's definitely a deep topic. This is something I've in my classes, we spend half an hour on this, and even that's not enough time. So don't worry if you don't quite get this, but basically that there's this idea that a group of objects work together, and there's no objective way to divide this. This is totally up to how the business works. Do I want to edit these things simultaneously? Does it make sense for me to edit the buyer's information while an order is being placed? If they're going to be edited by two different people conceptually, then they're different aggregates, but sometimes that doesn't work. And so there are all sorts of trade-offs. So the last thing I'll say about aggregates is basically the repository is the thing that is basically our facade. It simplifies the way we think about storing and retrieving aggregates. Is this being stored in a database? I don't know. Maybe it's stored in a NoSQL database. or a relational database, or some service that I don't even know how it stores it. I just send it JSON. Doesn't matter. The repository says nothing about how it's persisted. All it says is you want to find aggregates so that you can do some operations on it or get some information from them. You talk to the repository. And if you've got multiple aggregates, you will have multiple repositories. So if you've got this setup, you probably have an order repository and a buyer repository and a product repository and a whole bunch of other repositories. So those are the things that go inside the hexagon. That's where all of our precious, complex, valuable behavior lives. Now let's focus on how do we communicate and get communicated with the outside world. All right, so we've got our core domain, entities, value objects, grouped together as aggregates. We've got repository, some thing that represents a way to retrieve and store aggregates, and other services that provide that. And then we've got adapters. Right, so we've got inbound adapters, again, that basically drive the behavior. So you'll sometimes see, if you read about hexagonal architecture, you'll sometimes see these adapters on the left being referred to as driving adapters, because they're the ones that are initiating and driving the system to do stuff. Then you've got the outbound adapters along with ports. These are the things that are driven, right? As a result of something happening over here, something that ends up happening over here. Doesn't just happen over here out of nowhere. It has to have been triggered by something happening on the inbound side. Now, one other difference, so hexagonal architecture was not written up as a specification, right? It was basically, here's a pattern that I've seen, right, that Alistair saw, and I think it's useful. It doesn't always mean that you will apply it exactly the way described, especially the way he described it was a little, in some cases, unclear. I remember being very puzzled by it when I first read it. It's not, it's more valuable than the actual initial writing made it appear to be. And the reason I mention that is because these ports, which in Java would be pure interfaces, and in C# would likely be the same thing. They define the contract to how we want to communicate with the outside world, but leave the implementation to the adapter itself. So everybody does that when they talk about hexagonal architecture. What's different is some people put ports over here on the inbound side. I don't, because to me, when I develop a system outside in test-driven development, the direction of development, sort of the order that I develop things, is actually left to right. And the way I do coding is I don't introduce interfaces. Again, this is Java specific. I don't introduce interfaces unless I need to test them. Whether you introduce interfaces here or not, there is, though, you can sort of think about these conceptually as this layer is really another port that these things plug into, but they don't need to be abstract, right? Because the implementation is here, whereas here the implementation is outside, and so we need to keep ourselves ignorant of that. So the adapter role, right? It's not just a single class, it's actually a set of classes working together. You may have a class that deals with getting HTTP requests and processing those, and then other objects that do other work. And all those together get packaged up into a single namespace, a single package that represents that adapter. So the purpose of the adapter is to translate and transform the outside world and its intent. What do they want? What do they want to do? What information do they want to see? And basically translate and transform that from the outside world to the domain and back. The other thing about adapters, and this is why it's great to have them sort of isolated and packaged and separate on their own, is that they often change more frequently than the domain does. And so having this clear separation means the things that change at different rates are separate. So if we walk through at sort of a conceptual level of an incoming query, what's the balance for account number 123? So the request comes in, and sometimes we might get that as a string. So we have a string that's 123. Then we need to do some initial validation just to basically make sure, could this possibly be an account number? So we do validation. This is happening inside the adapter. So once we say, yep, that looks like it could be an account number. I don't know if it's there. I don't know if that account number exists, but it looks like an account number, because that's all the validation you can do at this level, right? This is purely sort of almost syntactic level validation. Like, is this a number? Once we have that, then we can talk to our hexagon, right? Our application and core domain, and say, can you parse this and actually make it into an account identifier? So it does that, and now we have a domain object. This is a value object. This account ID here, this is a value object, and it represents an account number 123. We still don't know if it exists, but at least now we have an object as opposed to just a string. And then we can pass that in and say, hey, can you go, I want to get the balance for this. So the application layer goes in and says, okay, let me find this account by ID. However it's retrieved, that's not the application layer is concerned. It calls a port and says, hey, find this account number by this ID. Assuming it's found, we get the account, right? So now we've got a domain object that was retrieved and loaded from wherever. And then we transform it into a data transfer object. So this is the way we send information out, because we can't send this account object. It doesn't sort of fit into the outside world. It's meant to live within the inside of our application. So it goes into the adapter, but then the adapter is responsible for transforming it to a data transfer object. So that might do things like format it. In addition to converting it maybe to strings for easy display, it may also format it with appropriate decimals and currency symbols. And then it returns it to the framework to be sent on its way. So at a high level, that's what it's doing. If we dive deeper into, okay, so what does that look like at a code level? So another way we can look at this is as a sequence diagram. But basically, these are the things that happen, right? We listen, wait for triggering an event. We validate from the outside world. We convert that unstructured info into a domain object. Whatever we want the service does its requested work, we transform that domain object to a response DTO, and then we return that DTO to the outside world and let the framework figure out what has to happen after that. In the frameworks that I use, Spring Boot, basically it would convert a DTO into JSON for me, or XML if that's what I need. So this is the sequence diagram, and it's exactly the same process as we just saw. But here we can see a little bit more clearly what are the different parts of the system. So the stuff that's in this light blue, that's our adapter. That's our inbound adapter. The stuff that's in this sort of peachy orange here and here, that's application. And then our core domain is sort of nicely nested deep inside and protected from the outside world by the application layer. And so what happens is, again, the API client makes a request. Our framework translates that request into a method call with a parameter. We then go and ask our core domain, please create a domain object, a value object for that to represent the account ID. And then we call our application layer to go ahead and please find the account for this and then give me the balance. So it finds by the ID, goes ask the account repository for that. It's responsible for loading this object into memory, and it returns it back into the controller. Now we've got a domain object, but we can't just throw that out here. That's not going to work, and we'll see why. Can't just return that. It's not in the state that the caller wants. So we convert it to the DTO. And what that does is basically just collects information, does queries, right? Getters, not getters necessarily for the domain object, but it does queries against the account object to find out, hey, what's your ID, so I can make sure I've got the ID, and what's your balance, so I can make sure I've got that. And then once it's gotten that information from the domain object, that's it. The domain object is no longer needed in memory. I got everything I wanted out of it. Right, all I wanted was find out the balance. I got that, and now it can be thrown away. And if another request comes in, it will refetch it, and maybe it'll be cached, maybe not. It'll refetch it, and at that point. So once I've gotten that information, I've now converted it into a data transfer object, something that's appropriate to send to the outside world. And then my framework will do the work of calling the getters on it for ID and balance in order to convert it to JSON. And then that gets returned to the requester. So this may seem complex, but with hexagon architecture, it's very clear who does what, right? Core domain, all it's responsible for is responding to commands and queries. You want to know my balance? Here you go. You want to deposit? Okay, I've deposited it. Now I've changed. It's up to the application layer then to trigger it, the domain objects from being loaded and stored wherever they're loaded and stored. So I'm going to skip this because we've seen this. So the reason why we can't return domain objects to the outside world is they are not meant to live in the outside world. They are meant to live inside of the core domain, because at least the way I do object-oriented programming and the way I name my methods is I don't have getters and setters on my domain objects. My domain objects have commands and queries. Commands where I tell them what to do, make requests that they change their state, what we sometimes refer to as behavior, and then requests queries to find out information from those objects. I'm very much anti-getter and setter. That was in the Java world, that was a mistake. That never should have happened. Getters and setters were meant for tooling. They were not meant for humans to use. And so my domain objects then have methods, like an account object here has a method deposit, has a method spend. Those are commands. They change the state of account, assuming that they're valid given all the constraints that you might have, such as, did you have enough money to spend that? And then there's a query. What's your balance? Looks like a getter, but thinking about it as a query, I find to be really useful. But we can't send this to the outside world because the outside world requires just data. We don't send behavior to the outside world. At least we don't anymore. We used to do that in the late 90s, but we don't do that anymore. With object serialization, we did that, but we don't do that. We just send data. But it's very hard to figure out what is the data, so we need to prepare the object for being sent out as data, and that's what the data transfer objects are for. So the job of, again, the adapter is to transform domain objects into data transfer objects that can then be sent to the outside world. So domain objects and data transfer objects, we can sort of now look at them and compare what are they? What role do they play? So domain object has domain behavior, right? Deposit, spend, draw a card, hit, stand, take a card, move piece, whatever it is, That's the domain behavior. And we access that behavior through commands and queries. Methods where we request changes in state, and then we find out what its current state is. There are some exceptions to this. I allow for getters and setters for data that's not owned by the object. So for data that's owned, information that's owned by that object, commands and queries are how you change it. Getter and setter, that's fine for things like identifiers, audit timestamps, things that are not part of the object's nature, right? I might need to store a player and its information somewhere, and therefore I need an identifier to be able to find and retrieve it. But that ID is not an intrinsic part of a player, right? We wouldn't talk to people and say, you know, is this part of the domain? It's not. It's actually part of the needs of the application, the needs of things to be uniquely identified. So for those things, for extrinsic data, that's the only place where I'm allowed to write getters and setters. Data transfer objects, though, they're only data. And because they're data and because tooling needs to access this, tools and libraries that automatically convert objects into JSON or automatically take objects and store them in a database using an ORM, those are pure data. Those have their attributes that data access through getters and setters, because again, they're accessed by tools. And at least in the Java world, they're Java beans, which basically defines that they have getter and setter naming conventions and have no behavior because they're not domain objects. They don't live in the domain. They live in the adapters. They may have some behavior that has to do with transformation, but that's not sort of intrinsic to the object. It's just transformation methods. So the rule is domain objects never leave the adapter. In addition to making it clear what's domain and what's not, it actually reduces coupling. So if, as I mentioned, the adapters can often change more frequently in their needs. Maybe an API needs to change. Maybe we need to change something in the way something is displayed on the screen. That happens a lot more often than the domain itself, our business, our domain, our game processes change. And so by separating out how the domain is structured from how is it represented and presented in the outside world, by decoupling that, by separating domain objects from data transfer objects, we make our lives easier. Plus, we have different adapters. So each adapter has a different way of talking to the outside world, right? There's one that's talking with text messages, there's one that's talking with a web UI, very different needs. And we wouldn't want to burden our domain with all the different possible representations. So we have data transfer objects that are in and live in each adapter, that are custom for each adapter. Right, so it carries this transformed data from the domain, right? Whatever we need for this API, right? The domain object might have a lot of information, but for this API call, we only need a little bit of it. So there's no point in even trying to transform the entire object. We just need a piece of it, a view on it. So that's about sort of the job of the adapters, to transform information and mediate requests, right? What is the intent of me clicking this button? What is the intent of this post incoming API call? It means change something. What is this implication of this GET request? It means I want to obtain information. And it's the job of the adapter to do that. So the adapter and its relationship to the hexagon has some rules about it. So the number one rule is that dependencies point inwards. From the outside world through the adapter to the application layer to the core domain, all dependencies point inwards. And that makes sense. If we think about how vertical architectures work, they tend to be top down. So it's the same kind of thing. Except for when you get to the bottom part, that's also top down in vertical architecture, not in hexagonal. So here in this diagram, you can sort of zoom in and see, yeah, so we've got our, let's say our user interface adapter. Yeah, it depends on the application, sometimes called use case layer. And in a language like Java, it's basically an import dependency, right? We have a reference to it, right? So our adapter class has a reference, some private field that is a reference to the application layer. And that gets injected at runtime, right, when the adapter is created. So that's an import or reference dependency. That's different from the dependencies on the right side. And we're going to shift to the right side in a bit. Here it's an implementation dependency, right? Because we can't have anything that's inside of our hexagon refer and depend directly on anything on the outside. So this right here, you may know as dependency inversion. We want our application to be able to talk to, and therefore depend on in some way, behavior around persistence and infrastructure and calling out to third parties. But we can't know concretely what those are. We can't depend specifically on Postgres or HTTP for an API call. So we can depend on and have a dependency to our port. That's fine. The port just says, I'll save accounts if you want me to, but completely agnostic about how it does it. At runtime, though, we're going to supply, right? So this is sometimes also known as an SPI, so service provider interface. We defined the contract in the port, and so then we just need some implementation that fits with what the port says it should do. And so the adapter here is saying, okay, you asked me to save. I need to translate and turn that around and figure out how to actually talk to that concrete database, Postgres, Mongo, whatever it is. So the other thing about adapters is, as I mentioned before, we have different kinds. We have one that might be initiated by somebody sitting in a browser using a web UI, and another one where somebody is sending messages in through text messages. And so how do we know how many adapters to create? The general rule, maybe it's even too hard to call it a rule, maybe it's more like a guideline, adapter per communication mechanism. So if I'm talking with getting input and returning output to a web UI adapter, that's one adapter. If I'm supporting API calls that are REST APIs or web APIs, then that would be another adapter. If I have two different APIs that have different needs, then I'm probably going to want to have multiple adapters there as well. So even though it may only look like one communication mechanism, they're all RESTful or REST-like APIs. One might be for some external system to communicate with us, and another might be for more of an end user API. And so I'd want to split those, even though those look like it's the same communication mechanism. So it's at least per communication mechanism. Sometimes you want to split them up to have more. So you end up with multiple adapters. Now, when you have multiple adapters, another rule comes into play. They need to be independent. They need to be isolated both from the hexagon itself, in a sense, right? That they depend on the hexagon, right? The hexagon does not depend on adapters, but also adapters don't depend on other adapters. If you have code that needs to be used by both of them, then you want to put it somewhere where they're accessible to both, but that they're not contained inside the adapter, right? Remember, adapter is also packaging and namespacing. And mentally, what I think about is, can I delete this adapter, right? All the code that's in this namespace or package, and does everything else work? It better. I should have the liberty to do that. So I've been talking about sort of the adapters and how we could basically unplug an adapter and everything should still work, or replace an adapter with a unit test suite of tests, and that should be fine. We also need to test inside the adapters. And for that, we may have to do some integration tests, right? We want to make sure that the adapter talks to the hexagon in the right way, that it talks to the application, that it calls the right methods in our application layer. So we can write tests for that. now we're possibly in integration test land. So we end up with, in terms of our adapter testing, whereas inside the hexagon, we had only unit tests. Life is great, but it's really nice because that's often the hardest code to test. Very intricate edge cases. It's not that testing integration stuff is easy, but it's a different kind of difficulty. So when it comes to adapters, we often have unit testing because there's code inside of an adapter that's just code, doesn't really interact with anything, and integration testing where you're testing it. Did I set up the framework properly? Did I configure it properly? Does it respond to gets to this endpoint? And so we end up with something that looks like this, right? We've got our hexagon, we've got lots of unit tests, right? All these tests are contained within here. Then we've got some integration tests where we get something coming in from here, touching our core domain, and then coming back out. Uses a port, but that's going to be a dummy here or a stub or some test double over here. And then we might have sort of end-to-end tests where we have tests that run through the entire thing using a real database. We'll have a few of those, more of the integration tests, but mostly unit tests, just like a good testing pyramid. So the last thing I need to talk about now is ports. So ports are, as we've seen already, is the way that we separate the implementation and the runtime devices, databases, and so on from basically the abstraction around that, right? We want our domain to be able to talk to these things without depending on them specifically, right? So we've got our persistence adapter, and we have other kinds of adapters. Any time that we want to initiate communication, right, as a result of something coming in, right? Oh, we wanted to deposit £100 into our US dollar denominated account. Well, we got to convert currency. In order to do that, we need to initiate some communication to the outside world. Well, we can't talk directly to the outside world. We would have to go through a port, and then we'd have an adapter that specifically is created for that service. And the nice thing is you could have the same port. Hey, please convert this amount in this currency to this currency. And you could have different adapter suppliers. Maybe you have different ones depending on where the system is deployed, right? So at startup time, you configure, oh, here we're in this region, we need to use this service because it's cheaper from this region. So when we implement the outbound adapters, say we want to test our outbound text messaging, there are 3 steps. So when you're coding this, you basically create the port. How do we want to talk to this service? What does the method signature look like? What are the methods we want to use? And then we test it using a SPI or other test doubles. And so what we're making sure is, does our domain code call this method, call the correct method at the correct time with the correct parameters? So in Java, this is what the interface might look like for sending out a balance change notification. And then we use a SPI to test. And so what that does is it basically says, hey, we want to make sure that this balance change method was called when we did a deposit. That's all we care about. When we did deposit, did it call the balance change method with the right amount? Once that test passes, we know that the domain is hooked up, and whatever concrete adapter we plug in will do the right thing. And then we create the concrete adapter. And that might be easy. If you have an SDK and there's not a lot of work, it might be more complicated. But all that complexity is in the adapter. And if anything goes wrong, well, you know the domain is calling the right thing at the right time. So you know it's got to be the adapter that is problematic. So remember, the repository is just a special kind of port. And so it therefore is ignorant about the specific kind of persistence, right? It's ignorant about the specific database technology or whatever is used. But it still has all the features of a port in that we don't directly put our domain objects in the database. Now, this is a point of contention. Some people say, what? I have this wonderful ORM and I can paint my domain objects with all sorts of different annotations and get it to work the way I want. It's like, yes, you could do that. I only have experience in the Java world, and I know that it looks very alluring, but you've now coupled your domain object structure to conform to something that's storable, even with a bunch of annotations in the database. And eventually you're going to want them to vary enough that it's going to be painful. So I don't do this. Instead, we have a port. Domain objects get sent through the port, and then the repository adapter, just like any other adapter, transforms those domain objects into DTOs, what I actually sometimes call DBOs, to represent that they are database objects. And then at test time, I can just replace this with a fake. And it might just have an internal hash map that stores these things. But in fact, I'll usually start with a fake, implement my code, get it tested, and then I'll worry about implementing the adapter to do the real thing. So one of the nice things, at least in Java, and I think there's something available similar in the .NET world, is ArcUnit. Right? So because we have a very well-defined way of talking about what objects go where, what can depend on what, right? Adapters can't depend on other adapters. Adapters' dependencies go inward. Application layer can depend on ports. Domain, core domain, entities and value objects cannot depend on anything other than those objects. We can write rules that can be evaluated using a static analysis tool, and ArcUnit is one for Java. And it will enforce, it will basically be a test that fails. So hexagonal is, I think, is really great. There's not a lot of overhead. It's just basically saying, where do you put your code? Where there might be overhead is in the transformation of your core domain to your repository and to the outside world. So if you don't really have much of a domain, then there's no point in using hexagonal. Right? If you've truly got a basic CRUD where there's no domain logic, then again, don't use hexagonal, use a code generator. You're likely, though, going to have some kind of domain logic, and the overhead is really sort of linear to how much domain logic you have. If you're just transforming things, right? You've got incoming messages, you transform them and just write them to a database. Yeah, hexagonal is not gonna help you much. So with hexagonal architecture, you focus on the core domain. Right? That's its purpose, and that's why it fits so well with domain-driven design. The domain objects never leave the adapters. Their purpose is to serve your domain logic and not have to worry about how they're going to be represented in the outside world. Adapters per trigger or communication type or per use case or user. You create your ports as the ideal interface. How would I like to communicate with this thing? Not what is the ugly SDK that's actually supplied or the ugly API that somebody's offered. Dependencies point inwards. That way, core domain doesn't depend on anything. Application layer only depends on domain and ports, makes everything unit testable inside, and then makes the external adapters easily integrated into your application. And you package based on that architecture. So that's all I got for you. There's, I'm sure, lots of detail that we could go into, but I'll answer questions for the time we have available. As I mentioned, I have a course based on this material where we dive deeper into this. So if you go to refactor to hexagonalarchitecture.com, you'll see the sign up page. But I'm happy to answer any questions at this point.
I have one to kick off. How about logging?
Good one. So logging is interesting because it very much, at least in the Java world, sort of is very much like the service provider interface kind of way of thinking about it, right? I don't know what logger I'm using. All I have in my code is logging statements. I don't know where it goes. And so you can think about a logger as basically a port. I've got some interface and it's got debug, info, warn, and it takes these parameters. But how it actually gets executed at runtime may actually differ from environment to environment. So since logging is I/O, treat it the same way. But a lot of times you don't even think about it that way because, again, at least in the Java world, it's always been that way. You always supply it at runtime.
Okay, sure. Thank you. Any other questions? I had a load of them, and then towards the end, I think you answered all of them. So,
all right, great. Well, if there are no more questions, thanks very much for your time.
Sorry, yeah? Can I ask a quick question? It's about something you said at the end that's something like, oh, this confused me. It's about the idea of your port should present the ideal interface. So it's how you want to present that internal domain data. But then we were saying we have a different port for each of the different external bodies you're talking to. Mm-hmm. Assuming that we've got the ideal interface in there and the adapter's adapting for who we're talking to, would those ports always be per outbound adapter, or would they be shared across different adapters?
So it depends on what you want those adapters to do. So for example, with my currency conversion example, so the ideal interface is I want to give you an amount, the current currency it's in, and the target currency. I may then have to write an adapter that has to translate that, and I specify the currency using my Java-based currency identifiers, and it has to translate those into symbols. So that transformation of the domain concept of Great British Pound and US dollar, I have to translate those into USD and GBP. That's the job of one of these adapters. In addition, it has to actually talk to whatever service is actually going to implement that. And that might be a very straightforward API call, or it may be a very complex API call where I have to first retrieve the currency and then I have to go take that and then make another call to retrieve another currency. And then I take those and make a third call. But all that is complexity is hidden in the adapter. But I may want to choose a different one, probably not at the same time. It would probably be there'd only be one implementation of this port, but I may find, oh, hey, we want to replace it with this other one that's cheaper or easier to use. And so that might be selected either when we are ready to deploy it or at runtime. As I said before, you may choose a different one. But each port, there's meant to be one port per what do you need from the outside world. Right, one port for storing orders, one port for storing, for sending messages to the warehouse to go ahead and ship that.
Okay, that kind of makes sense.
Yeah. But you may, all the work of retries and resilience and what happens if it doesn't work, that's really mostly up to the job of the adapter.
So if I was sending a text message, a Twitter message, or other message, I might use the same port because it's the same information that's going out.
Right.
Yeah. Okay.
Yeah, and so that's an interesting one. Is what if I want to send a text message and an email? That might happen, right? Because maybe I don't check my email often, but boy, I check my text messages. Your adapter could decide to do that, but at some point, that's probably going to be wanting to be pushed into the domain where the user selects how they want to be communicated, and then you're basically have to figure out: do I want two ports for that? So is the decision at the adapter level where it's saying, oh, I couldn't send a text message through this service, I'll send a text message through this service, or maybe I couldn't send an email, so I'll send a text message, right? And so where that sort of logic of choosing might be in the adapter, but it might also be part of your domain. All right. Any other last second questions? If you have questions outside and you remember them later, or you thought about them, or you had other questions, many ways to contact me. Email is fine, ted@tedmyoung.com. I'm on Twitter at JitterTed. I've got my website recently revamped. So feel free to contact me in any of those ways if you have any questions. I also have a Discord community where we talk about this kind of stuff. So thank you very much. Appreciate all your time.
All right. Thanks very much. That's excellent. What to think about there. So we'll move on to our next speaker, Marion Duncan-Jones, and a switch in context now and subject. We're going to be talking about event sourcing and CQRS on Azure. So
thank you very much. Let me see if I can get this working. So I want to share a window. And which one of these many ones is it? It would be that one, I hope. How's that looking?
Yes, we can see that.
Okay. So yeah, perfect. My name is Duncan Jones, and what I'm hoping to talk to you, what I'm going to talk to you about, what I'm hoping to get across is about event sourcing and CQRS. A lot of the more CQRS stuff has been covered by what Ted was talking about there, so I will probably just keep it more event sourcing at the moment. So let's get started and see how it goes. So agenda. First things first, I'm going to talk about the motivation, why you'd want to do this in the first place. I think that's a useful thing to do, because obviously if you don't have that motivation, there's no point going into all the detail of this. Then an introduction to event sourcing. I'm going to do a sort of walkthrough Hello World example. Following the theme, I'm also going to do managing budgets for children. Seems to be the thing that's done these days. And then I'll pause for a Q&A, because basically, having explained event sourcing, everything else follows on from that. So kind of make sure that everyone's on the same page with that. Then I'll also discuss how you would do it in Azure, and how notifications and Event Grid can be added on top of that. Okay, so let's start with a couple of caveats. So the first thing is that the system I'm showing here is sort of more of a small show and tell thing. It's not an industrial like fully production version or whatever. So so that's the sort of swing set, not nuclear power station thing. And the second caveat is that it's sort of an experiment rather than a definitive, this is how you should do things. So I'll tell you what I did and why and what happened, but by no means should that be taken as like the authoritative way to do event sourcing. Oh, and a third caveat, just throw in, if I mute very suddenly, I've got a bit of a summer cold, so if I mute very suddenly, it's because I'm either going to sneeze or cough, so I apologize for that in advance. So motivation, why would we do this? So with serverless, your big motivation, well, the motivation that always gets given to me is to reduce cost. So when you have a serverless system, you basically want it to reduce down to the usage, so that if you're very busy, you scale up, but if you're not very busy, you want to reduce down and not cost the earth. And a lot of state systems, so databases and things like that, have fixed costs because they're basically always on. You always need a server for the data to be stored in, and you always need some way of communicating with it. And similarly, there's an over-provision thing where, if you have that, you basically have a number of servers on. When the demand drops, you basically want to go down with that. So what is event sourcing? So as I said, I'm going to use a similar sort of example, sort of managing budgets for children, and essentially to explain it. So I'll give you the 10,000 foot thing. So event sourcing is, instead of storing the current state of things, so entities or whatever, what you do is you store the history, the entire history of those things, and then you derive the state for them. So if I was to give you this example, let's use the bank account example. So I have my three nephews, or two nephews and a niece there, and we set up a bank account for them. So the first thing that happens is that Aidan opens his account. So what we basically have is that creates a new event stream and adds the first event to it. So the first event is open account. He then deposits $10, which being his allowance, and that's that for today. Margaret comes along. She also opens her account, and again, you can see how you get a unique identifier there. So I'm going 002, but that's the identifier of the event stream, and also deposits $10. Fergal, the youngest, comes along. He opens his account. He, being the youngest, has already spent half his money on the way to the bank, so he only deposits $5. Excuse me. So that's the end of day one. Then what happens is that Aidan, having seen what Fergal wants, decides he wants to buy that, so he withdraws the $5. Margaret sees how this bank is being run. She decides she wants nothing to do with it, so she withdraws all her money and closes her account. And that's basically, you can see the history accumulating there. So that's how you get data into an event stream. The question is then, how do you get the data out of it? And this is done by something called a projection. And a projection is a really simple piece of code. Well, I think it's very simple. It has two purposes. It walks through the event stream, and it basically says, for each event that I encounter in the history, first question is, do I care about this this event? And the second is, if I do care about this event, what do I do about it? So projection to get the current balance of a bank account, for example, you basically start with it and you say, okay, if the event type is open account, well, that doesn't have any impact on the balance, so I just skip that event type. If I come to a deposit money event type, then I increase the balance by the amount that's in that. And if I do a withdraw money, if I encounter a withdraw money event, then I decrease the balance by that amount. You can see after event 1, my balance is $10. After event 2, my balance is reduced to $7. And one other thing I always do with the projection is you always return the event number that you were up to when you return that value. So that allows you to basically to return a value and to know, okay, it'll always be the same for as at event number 2. If new things come along in the future, I can say, okay, my balance was $7 as at event number 2, and I can continue the projection from there. And for most types of projections, it's actually possible to do it that way. There are some types of projections where you are going to have to run the whole thing from scratch, which is perfectly okay to do. But for most of them, you can actually store a sort of snapshot. You say, as at event number 2, this was my projected balance. So some rules that basically hard and fast rules. So event streams are append only. So you cannot delete them, you cannot reorder them, you can't do any messing around like that. And that's basically to stop undoing of that thing I said previously, that basically as at event number 2, this was the state. Now, the obvious question that's going to arise out of that is, what happens if we've made a mistake? So, we should have deposited $3 and we actually deposited $4, we recorded $4 and in fact they only deposit $3. And the answer is you have to do a reversal and a rebook or some kind of balancing transaction to bring things back to what they should be. So you could quite happily have, event number 4 deposit and then a withdrawal to undo that deposit to get you back to like a known good state, and then you carry on from there. And then the second really hard and fast rule is that the events themselves are immutable. So the content, like I can't edit, if I deposited $3, I can't edit the event to say actually it was $4 or any other such thing. And again, that's because if you were to do that, your ability to say I know what the value was as at event number 3, that would fall apart. some guidelines. And I'd actually say do your very best to follow these guidelines, because it can get very confusing if you don't. But the first guideline is, so event names are past tense and they are business meaningful things. So don't say amount change or anything like that. Just say, a withdrawal or a deposit or whatever. So you're talking in the domain language of the business, and you apply the event names that way. And the second one is, an event can only happen to one entity. So essentially what that means is, if you have a business event that occurs across two entities, those entities each get their own impact of the event. So a classic example would be a balance transfer between bank accounts. So the outgoing account would get probably a withdrawal account or withdrawal event, or some kind of transfer initiated event, and the recipient account will get a different event that is the amount being received, or however you want to perform that. But basically, you can't put the same event on multiple entities. So that is the really, really 10,000 foot explanation of what event sourcing is. And as I say, because basically everything depends on that that overview, I will just pause here if there are any questions, because it only gets worse if I have failed to explain something, or if there's anything troubling you at this stage. So if there are any questions, just go ahead and shout them out, or however you want to do this.
Duncan, hi.
Yeah.
It's John here.
Yeah, sure, go ahead.
So I've got quite a few questions, but I'll keep them brief, because it's something that we've been looking at where I am. It's certainly a topic of interest. But probably the bigger question I have, if we set one of these systems up initially, that's fine. But if we've got a system that's been running for about 3 or 4 years, I assume that we're going to have to retain the entire stack of the history.
You basically are, yes. You can. So when I was talking about the projection that could have an as of date. Yeah. So there is a business thing where, and again, this is totally driven by your business. It's not a technology thing, but some businesses have the thing where they close the books, or they say, so accountancy is a very good example. We say, okay, year end, we had 3,000 in profit, and then you have a start event for the next year. So in that case, you can clear out your history. But I wouldn't, basically. And the long and short of it is, these days, storage is basically free. So, that's a little bit facetious, and the CTO people don't like that. But essentially, it's really, really cheap. You should keep all of this, because it may be that in the future, you come up with another projection, another thing that you want to question your data with, and it's always good to have the full history of your data to go over. And so the secondary concern then, other than storage, is going to be speed. But the thing is, projections are really quick, because it literally is, do I care about this event type, and if so, what do I do? It's pretty much the one of the fastest sort of bits of logic you can do, as long as you keep the code close to the data. So you don't want, fetch from the other side of the world event, deal with it, fetch the next event, deal with it. You do want to keep your code and your data close together.
Yeah, that makes sense. Have you had much experience of taking a brownfield project and potentially converting it? Or is it always something we start getting a degree?
Yeah, no, I have. In fact, that's exactly my experience. It was that. It was an accounting system, but we did a sort of, I'd call it a strangler pattern. So essentially what we did is, we had a bit of the application that we event sourced. And that's another thing that I would say is, it doesn't have to be your entire architecture. There are many types of data that it doesn't make sense to put in event sourcing. So, if a thing doesn't have a meaningful history, it just has a current state, I can't think of an example. Well, maybe things like user ID or is logged in or whatever. There isn't really much value in keeping the complete history of logins and logouts that I can think of. So that, you can have that in a database or in a file, a JSON, whatever, and it's not a problem to do that.
Brilliant. That's pretty much it.
Okay, is everyone else is good to go, or is that? Okay, we'll carry on. But if there is anything, just shout out and we'll pause at that page. Oh, a walkthrough example. So we're talking about this same bank system. If you throw that URL in a browser, it'll bring up the quite horrendously ugly user interface that I've created for this. But essentially, it's just showing you how this would work in the bank account thing. So we start with the first event. So we're opening a new account. So this is, again, you define this by the business. So the business come in and say, I have this requirement as a user. I want to open a new account, etc. Your constraints in there are that each account number must be unique. And we're also allowing you to deposit an initial amount and also set the beneficiary. So again, as I say, very simple bank account system. If you are creating a bank account, don't start with this. Like, go a little bit higher, because the FCA will be all over you if you don't put in a few other things. But anyway, this is the rule for opening an account. Each account number must be unique. There's a bit of a thing here, so there's a concurrency issue, and one of the things that is different about event sourcing is that concurrency isn't handled for you. So in a database, you can do transactions, you can do all that sort of stuff. In event sourcing, we basically say, okay, it's up to the developer to put in the concurrency controls so that different commands can have different concurrency levels or different concurrency rules. So for this one here, we're saying, okay, each account must be unique. Well, obviously, if two commands come in with the same account number, we need to work out how to prevent them from both attempting to open the same account. A bit of code here in C#. So basically, all this is an Azure function, and what I'm basically saying is, okay, open account number, and I'm passing in the event stream, which has got bank account and account number. So this is my way of uniquely identifying an event stream. And bank account number is just like a three, it's like a stepped identifier. So you've got domain, entity type, and then entity instance. So bank is the domain, account is the entity type, and your account number, which you'll be reading from your URL, is basically your unique number there. And that's the bit that's basically going to set up the new event stream. Now, what I have as my concurrency rule here is basically saying that if the bank account already exists, you've got to throw an error saying it already exists, and then you're firing in the new event, so the opened event. But it could still happen that even with the outer if there, it could still happen that two ones enter the else part because of the latency. They could still be that. So there's another bit there, which is the stream constraint, and that's basically saying if when you go to append the event, the event stream already exists, I want you to throw an error. So that's what the event stream write exception is, and that's how you're enforcing the concurrency as the developer there. So that's for a new account, and basically what we're doing is saying, okay, if there's an opening balance, we also want to create a deposited event, and if the client name is there, we also want a beneficiary set event. So it just shows you how one external command can turn into multiple events. There's no need for it to be a one-to-one mapping. And then basically this is how it's stored in. So I use Azure Tables, so it's just a NoSQL type of thing. So it's just partition key and row key are just saying the partition key is the unique identifier of the bank account. Row key is just literally the event number. It's saying, like, they start from 0, you go 1, 2, 3, 4, 5, whatever, and that's your history. And then the event type there, I'm using a readable version of it, which is ever so slightly slower, obviously, because it's string matching. But it works well enough. And basically, what I'm saying there is, those are the event types that have occurred in this this account's history. So this here, the first row is also just a way of keeping track of, where, like how big the sequence number is and whatever. So I don't have to do a sort of run through all the events if I want to append one on the end. That's that's your event description there. This one doesn't have any parameters except for the opening date. And then the ones below have got more parameters. So you basically get a NoSQL thing of all the different parameters in your events. Making a deposit. So making deposit, the rule is that the target account must exist, and you've got a deposit amount, and you can put some more text in to say where the deposit comes from. There are no concurrency rules in making a deposit in this bank, obviously. So we just go ahead, as long as the account exists, go ahead and make it. So all we're saying is, if the bank account doesn't exist, throw out an error to say it doesn't exist. If it does, go ahead and put in the money deposited event, and it just basically appends it to the end there. So getting a balance, this is we're running a projection here. So to get the balance, we're saying, okay, the account number must exist, and then we can also pass in the as of date for this, when this balance is. And this exposes basically one of the most powerful things about event sourcing, is that because you've got the whole history of events that have ever occurred to this bank account or this entity, you can run it to any given point in time and get the balance as at that time. You don't need any additional sort of snapshot tables or anything like that. You're basically saying the entire history is there. If I want to run the history up until the end of last year, I will get the balance as of last year. And if I want to run the history to today, I get the balance as of today. Again, we're just going to run a projection. Projection is exactly the same thing. We have the identifier, the unique identifier that's going to run over, but also the name of the projection. That's just a way of it looking up what code it's going to run. But essentially what we're saying is, for the bank account number that's passed in, I want to run the balance projection. And basically all that does is, you can see this, this is the code for running a projection. It's basically saying the only events I care about are money deposited and money withdrawn. So it'll skip over every other event. And then basically you can see when I'm handling a money deposited event, I increment the current balance. When I'm handling a money withdrawn event, I decrement the amount withdrawn. So that's really simple piece of code. You would probably put in things like error handling and all sorts of other excitable things like that, and logging and things like that if you're sort of a proper production thing. But even with all that, you're left with a very simple bit of code to run. And basically we're saying for that event, this is what we do with it, and then go on like that. And then basically what it's doing is we run that projection. So we're saying process it up until the as of date, and then just return me the current balance. And what it also returns, as I said earlier, is it also returns the current sequence number. So this is quite useful if you want to take snapshots of your data. So like my current balance was $500 as at this point in time, and you can then use that as snapshots for your data. And then basically, if you do it from an API or whatever, this is basically what you're going to get back. So it just says balance is 2139 as at record number 14. Withdrawal, you've got two constraints here. One, obviously, we're still with this thing where the account must exist. And then the second one is that the balance must be greater than or equal to the withdrawal amount. So what we're going to have to do here is we're going to have to run the projection. We're going to have to see that that is valid. And then we're going to have to, if it is valid, we're going to have to append the withdrawal amount. Again, there's a big concurrency crocodile here, because running the projection is, like, all of this is asynchronous. Somebody else might sneak in and put in another event in while you're processing the withdrawal. So when I was a student, I used to try and do that all the time, but that's the way things are. So again, we've got the event stream that we're going to append our withdrawal event onto if it's successful, and we've also got a projection that we're going to run to get the rule to apply. Unique identifiers, so bank account and account number.
Duncan, can I just ask?
Of course you can.
Just go back a slide first, please.
Sorry, to go back.
Yeah, those output bindings there, are they custom output bindings?
They are, yes. They are. They are in a project which I'll share you the thing, but it's literally, it's a little tiny wrapper around reading and writing to the Azure table. There's a little bit of code that just says, in order to do event stream, that turns that into a table name and a bit of code, and then the projection one turns that into a table name and the query to
Is this source code on GitHub?
It is, yeah.
Brilliant.
Yeah. The code on GitHub at the moment is fine. I have comprehensively broken it on my machine, so I won't check it in, but I hopefully will comprehensively unbreak it again soon, and it'll be good to go. But essentially what happened is there's a different SDK now for Azure tables, and it is utterly incompatible with the old one, so I'm trying to make it work with the new one. That's the way of Azure, I'm afraid. Okay, so what we're doing there is we're saying I'm going to run the projection, which we've processed there, and it's saying if the balance is greater than the amount withdrawn, then we're going to append the withdraw amount. So if we've got sufficient balance. But this here that says the sequence number that I got from my projection, so I'm passing that into the append event. If the event stream has moved on beyond that number, so if I got my balance as at event number 13, if I'm going to write this event stream and the current maximum maximum sequence number is 14, this is going to throw an error. So we're basically saying, there was a concurrency error. How you handle that is entirely up to the business need. So you could, for example, retry it, just do the withdrawal again, because say, okay, somebody else was making a concurrent thing, or you could just say, whatever, it's a disaster, I'm going to throw an exception. In this case, just for simplicity, it just throws an exception. But essentially, so this is the thing, the output you get from the API. You've done a withdrawal that is in excess of the balance, so you get back this thing that says you don't have sufficient funds for the withdrawal because the current balance is 2189, and both of those bits of data are available. Sorry, excuse me. The current balance is available because you ran the projection as part of this thing. So, questions on that bit? No? Okay. As I say, if anything comes up, just shout it out. So notifications. So when I'm doing all these things to my event stream, it's quite good, and I'm able to store state, but I haven't really done anything that isn't, the same as a database, really. Notifications is a way of basically having a change feed that's a little bit more businessy than a database change feed. So what we're saying is when I create a new event stream, I throw out a new entity notification. So that's, it's put on Azure Event Grid, and other things can listen into it, and they can initiate an action. So, I mean, a very good example, if a bank account was created, you probably want to initiate some kind of anti-money laundering process, some other, all the different processes that go on. So basically, you can sit around and listen for the new entity notification, and if it's bank and account, then you take the instance data and you start whatever your second process is. And similarly, every time an event is appended onto the end, we get the event details as a sort of the event thing happened. And in this case, rather than new entity, I actually have the event type. So it would say, withdrawal, deposit, etc., and they can then be listened to on Event Grid. Similarly, when a projection is run, it also sends out a notification. The reason for that is you essentially don't want to ask the same question twice. So if I have run a balance notification projection, and a downstream system can listen to that and can be basically just getting that information as it occurs. So you could have sort of a end of day view of your account that basically just listens to these, and it doesn't have to run any more queries. Classification is just another form of projection, which I kind of, it's a more detailed thing. I won't get into it here, but it's basically the same sort of idea. And basically what we're saying is Event Grid is just it's a pub/sub system with some clever routing logic thrown into it. So what I'm using it for, or so the way that I'm using it, sorry, is that I'm passing in custom topics, which are the different domains and entity types, and I'm triggering Azure functions from it. So like, kind of like a reactive type of application. But you can also trigger a whole bunch of other things, logic apps, which are just, they're basically similar to Azure functions, but you kind of go code them, you draw them together, and webhooks and things like that. But there is one thing about Event Grid, which is it is an always-on thing. So you pay a continuous amount of money for it. Excuse me, I'm going to have a bit of coffee here. Oh dear, excuse me. So what that means is that you are going to pay an amount of money, but it is a shared thing. So that amount of money isn't substantial. It's just a fairly small amount of money. This. Yeah, so Event Grid is also at least once delivery. So your recipient things need to deal with the fact that they may receive the same message twice. And in fact, the truth of the matter is, under high load, it can be twice, 3 times, 4 times. It can get quite ludicrous. So what I would do is I would use the identifying bits of that message, use of the key, as store that for a day or whatever. And if I've already received it, don't process it again. And the filtering, as I say, you just basically you set up these filters in Azure, and that's basically the routing. So I'm saying that I have a function I'm going to call on new bank account, and basically the filter is going to be that event sourcing bank account, which is your domain, and then the event type is the new entity event, and it's basically saying when I get a new bank account, then it'll trigger that function, and you can write that function then to just basically be disconnected. Whenever it receives that notification, it does whatever processing it needs to do. And the content of the event source, of the event grid message is very similar. So I've got the outer bit, which is the event identifier, so notification ID, and then I've also got my domain name, entity type name, and instance name, and the projection name, and so on. It's just basically a way of saying this is the data that I have got when I ran this projection, and again, downstream systems can just listen to that and process them accordingly. Now, excuse me, I'm like that TED character. So, overview of an example of system architecture. This is just basically how can these different things talk to each other. So what I would do with event sourcing is I would never share an event stream between different domains. You could go into the you could use this in a hexagonal architecture as well. You're basically saying you don't share data, but you can communicate through, and it would be, notifications would be a sort of analogous to a port. You're basically saying this is how things can talk to each other, and your commands and queries are also come in through presumably REST or something like that, and everything has to hang together that way. Handling a command. So if you want to do something more advanced than just simply appending one event on the end, if you've got to do some logic in there, what I would do is I use Azure durable functions, and it's basically what you're saying is I'm going to use that to do a multi-step process to create your event stream for the command. So each, a command can have an event stream as well. It's something that can be uniquely identified. And basically what you do is you do your various steps and you write them back to the command's event stream. And what this allows you to do is at any given point to say, is this command valid? Is it complete? All these other things. And you have a sort of transactional ability there. You have a way of looking into well, actually, I would say it's more closely related to a Saga. It's a way of seeing what the command has already done, what it still has to do, and so on. And then, after it's validated, it then appends events to the underlying event streams of, say, the bank accounts, whatever the thing you're writing to is. So let's say we have a command and we want to apply interest to all the accounts in the system. Now, obviously, we're going to do that in parallel. So we just fire up a durable functions orchestration, and then we collect all the accounts, and then we fire off the apply interest command, and it does it all in parallel. And basically, for each one, it then fires off this sub orchestration. So just for this account, do the actual the interest calculation, and interest calculation would obviously be, you get the current balance, and then you get whatever the interest rate is, and you apply it that way. You can handle a query in a very similar way. So your query comes in, and basically what you're doing is you're putting an event stream behind the query, and then basically you do your validation, you run all the projections that are needed for the command, and you write those back to the query event stream. And then basically you can run over the query event stream to get the answer. So let's say I wanted to get an average balance. You do your query validation to say, is this valid to ask this question? Sorry, I'm going to cough again. So you run that, and then you get all your projections, and the answers from your projections get written to your query, and then you can do whatever your aggregation step is. You can say your average or your maximum or whatever you want to do. Oh dear. So that's the overview of the more. Oh, sorry, it's gone wrong again. That's the overview of the more complicated parts of it. Oh dear. And again, you just want to run all the projections in parallel. So you're basically saying request all the projections, and then what you'll do is when the answers come back, they get appended to the event stream, and you're able to read that off. So recap of the whole thing. We're using event grid functions, event grid function triggers to sort of do the reactive part of the thing. Event sourcing, the commands are done with Azure Functions. The stuff behind the scenes is done with Azure Tables, which is actually now part of Cosmos DB, but it's a separate NoSQL table implementation. Very very simple stuff. And then the query and command orchestration, that's done with what's called Azure Durable Functions. There's some clever code in there that manages the life cycle of the command orchestration. Oh dear, excuse me. So that's basically all of it. Just bring back to this. That's basically all of it. But if you have any questions, I'd be happy to take them now. I'm going to drink a glass of water though before I expire. Okay, apologies for that. Right, any questions?
Can you show your GitHub address again? Sorry, that was quite quick.
Yeah. This doesn't work as well in this clicker doesn't work as well in Teams, I'm afraid. Okay, so it's there. I can paste it to the chat thing as well as the URL of the kind of noddy user interface as well, if that's useful to you.
Yep, that'd be good. I think I found it now.
Okay, so that's the thing. Let me just bring you the. Just put a few more things in here. So this is the URL of the really horrible user interface. And if you want to very quickly look at the actual data in an example, let me just share a different screen. Try share. That one there. So this is an example of the data. So what I did is I created a new account, and what you've got there is the 3 events: account opened, money deposited, and then designated beneficiary set. That was from a single command. If I then go ahead and let me go and deposit some money into that. Good. back to that and refresh. So that's just the new event has arrived there. And I just put in some commentary and whatever, but you can see that basically the amounts are in there. And if you run the projection, you'll get the amount of whatever that is, 1,500. So okay, so that's, as I say, that is the long and short of how it works. There is a great deal more to be said about event sourcing in detail, but it kind of depends on how you're using it. So this example here is for serverless, so it's a very lightweight implementation because I don't have things like my own query language and stuff like that going on, where some event source implementations would have that. Yeah, so that's basically it. Oh, one thing I would add, you will probably be tempted, if you get into this, you'll be probably tempted to do this on top of Kafka. Basically, just don't. It's that's not what it's designed for, and it will cause you trouble in the end. So if you're doing this in a commercial setting, there are libraries like, or there's implementations like Event Store. I would use something like that. There are also libraries like Martin and a few others that have got all the stuff that you can fall over. They've already fallen over and baked it into their libraries. Just unshare that again.
Any other questions before we wrap up?
I can throw in some that I'm often asked. How about that? First question I'm nearly always asked is, what about GDPR or similar, whatever the US equivalent is now? Because I said earlier that events are immutable, and excuse me, and it breaks the rules if you edit the events. GDPR, the right to be forgotten, etc. How do you do that? Well, it is a bit difficult. Some suggestions would be crypto shredding. So you have your PI data inside your event protected by a key. And then if the person invokes their right to be forgotten, you just basically throw away the key. That does mean that any cached data that you have has also got to be regenerated and so on. So, that I would say is the answer to that. The question about storing history forever, again, like I often get that asked that, and the sort of fatuous answer is you get the salespeople to talk to the CTO and say how much more valuable data is than the cost of storage. So because it is basically being able to look over the spending patterns of bank accounts over 10 years is hugely valuable to a business. The cost of storing 10 years worth of bank accounts transaction data is almost zero, really. So yeah, that's worth doing. What else do I often get asked? Yeah, that's pretty much it, to be honest with
you. All right, well, maybe we should close it there then. Thank you very much for that. That's excellent. Thanks to both speakers this evening for two great talks. I'm not here next month, so I'm leaving it in the capable hands of Brett to organise everything. So keep an eye on Twitter and the usual events page and everything else for what's happening in July. And thanks everyone for attending, and we'll hope to see you next month. Thank you now.
Thank you.
Thanks, Noel.